P.6 Factoring, everyone's absolute favorite algebra topic. Factoring. So factoring an expression reverses the distributive property. So we say that x plus 2 and x minus 2 are factors of x squared minus 4. Okay? Factors are things that we multiply together. So if I think back to elementary school, I would say 2 times 3 is 6. 6 is the product, but 2 and 3 are the factors. So in this case, I'm thinking of them as the two things they multiply to get the product. There are many methods we learned in Algebra 1. GCF was the first one, and you should always try to take out a GCF first. We also learned grouping when we have 4 terms. We learned how to factor trinomials, whether A was 1 or A was something else. And then we also learned some special formulas, such as the difference of squares, or when we had that A plus B squared, or A minus B. So here are some of them. The only new ones are the last two. So that first one is that difference of squares that you probably know the best. Perfect squares, you could certainly do them without knowing that formula, but it is a nice, useful one to memorize. Now, the difference of cubes and sum of cubes, this is different than the multiplying one we showed you earlier. That was the sum, like being multiplied to the third power, whereas this time the answer has that sum and difference of cubes in here. All right, so here is the trick for memorizing the sum and difference of cubes, and you're going to think this sounds crazy, but you remember it using SOAP. SOAP. SOAP stands for same, opposite, always, positive. Okay, same, opposite, always, positive. So when I have A cubed plus B cubed, I remember SOAP, and that tells me my signs. This is the same as this one. This is opposite, so this was plus, this is a minus now. Always positive, whoops, that's a B. Always positive, that's always going to be a plus sign. What I do in order to get these answers is these guys are the cube roots of these guys. So I'm taking the cube root of A cubed, the cube root of B cubed. Okay, I'm figuring out what's the cube roots here. Then I'm taking this A and squaring it. I'm taking this B and squaring it. And then I'm multiplying these two guys together to get the middle. So if we do something like x cubed plus 8, right? I like to think of this as x squared plus 2, or sorry, x cubed plus 2 cubed, right? Because the cube root of 8 is 2. All right, so we are going to remember SOAP, same, opposite, always positive. This is a plus sign, so we're going to use a plus sign. The opposite, always a plus sign. The cube root of x cubed is x. The cube root of 2 to the third is 2. Square the x, square the 2, multiply them together. You're going to see that more, I promise. All right, so we're going to factor these guys. Always take out a GCF. So the greatest common factor in A is 3x. When I take that out, what I'm left with is an x minus 2. In B, I want to see what all of them are divisible by. So they all are divisible by 2. With the variables, I'm going to take the smallest exponent of all of them. So I see x to the first is the smallest, y to the second is the smallest. And then we write what's left over. So 8 becomes a 4 when I divide. When I take out one of the x's, I'm left with the third power, and the y's are gone from the first term. Let's see, that's a 3x squared y, and that x and the 2 are gone. We just are going to have the minus y squared. All right. In C, we do have a GCF. This is really counting as one term, and this is one term. They both have this x minus 3 in it. And that leaves me with 2x plus 4 minus 5, and actually I can clean that last part up. That's x minus 3 and 2x minus 1. Okay. Trinomials that look like quadratics. So back in Algebra 1, you probably said to yourself for problems like this where a was equal to 1, what multiplies to the last and adds to the middle? So things that multiply to 12. We have 1 times 12, 2 times 6, 3 times 4. Which of those are going to add to the positive 7 in the middle? The 3 and the 4. So that will give me x plus 3, x plus 4. We can do something similar in B, but the problem here is that's not going to cut it because of the 6. There are many options. Some people will use guess and test, and there is nothing wrong with that. However, it can be very time consuming, and most teachers will recommend guess and test because they'll give you smaller numbers. And again, there's nothing wrong with that. So if you wanted to guess and test, you would say, okay, well, we know that we've got that 6x squared, so maybe that's like a 6x and an x, or maybe that's a 2x and a 3x. Maybe those are the ways to get x, or 6x squared, right? And then for the other spot, we could have 1 times 5. So this could be a 1 or a 5. We don't really know in each of those. But then the other problem is because this is negative, this could be a plus or a minus. We don't really know. And now it's kind of getting out of hand how many options we can try. When the numbers are small, it's not so bad. And we can probably eyeball it most of the time. There is a much longer method you learned in Algebra 1, likely, called group or splitting the middle, some people call it, and then that turns really into a grouping problem. And again, there's nothing wrong with that, but it's time consuming. So I'm going to show you a trick, and it is just a trick. So if you want to do it the long way, guess and test, it's fine. 6 times negative 5 is negative 30. Similar to the first problem, what multiplies to negative 30 and adds to the middle? 1 and 30, 2 and 15, 3 and 10, 5 and 6. Okay, and one of them has to be negative to multiply to negative 30. We also want it to add to positive 7, so if we use 10 and negative 3, that'll take care of it. This is where it becomes a trick. I am going to take this number, the a in the front. We have 6. I'm going to make 2 fractions. 6 is my numerator. These guys will become my denominators. I am going to simplify them, but I am going to keep them looking like fractions. So if something becomes 1, I'm still writing the number 1. 6 over negative 3, that becomes 2 over negative 1. 6 over 10, both are even. That becomes 3 over 5. Here's the trick. These are the numbers I need to know for my parentheses. That 2 is the first number, 2x minus 1. The next parenthesis is 3x plus 5. Kind of a neat trick. You can FOIL that back and double check, or you can guess and test, but you might be here a while. In C, same concept. We could do that with a trick. We don't have to, but there would be a 1 on top, so we would never have to simplify. What multiplies to negative 3 and adds to negative 2? So if we have negative 3, that's just 1 and 3, no real options. Which one's positive, which one's negative? The 3 has to be negative for the negative 2 in the middle. So that is an x plus 1, x minus 3. Okay, now D looks like a quadratic, except this is kind of like my x. So what I like to do is either say let x equal, or sometimes let w, because sometimes there's already an x in there. So let's use let w. Let w equal 5a plus 1. So now this problem is w squared minus 2w minus 3. And I can factor that. I literally just factored a problem like that in C. That would have been w plus 1, w minus 3, and now I can replace w with what I let it be in the beginning. So that would be 5a plus 1 times 5a plus 1 minus 3, and then I simplify. So 5a plus 2, and that's a 5a minus 2. I could, and there's nothing wrong with this, multiply all of this out and then factor, but that would take a lot longer. All right, next one. Special formulas. So if we see A, that is clearly a difference of squares. All of those I can take the square root of. The difference of squares is just going to give me plus and minus, and we're taking the square root of both terms. So the square root of 4x squared is 2x. The square root of 25 is 5. So 2x plus 5, 2x minus 5. Very similar here. This is that first part. That's like a squared. So the square root of x plus y squared is going to be x plus y. And then we have a plus z. And then we have x plus y minus z. Okay. Now, this is a difference because of subtraction cubed. So we're going to remember SOAP. Okay. So we want to remember SOAP. We'll have 2 parentheses. One's bigger than the other. S-O-A-P. SOAP, same. So a minus sign. Opposite. So a plus sign. Always positive. What is the cube root of 27x to the third power? Cube root of 27 is 3, so 3x. What is the cube root of 1? Well, 1. Now what I'm going to do is square both of those terms. 3x squared is 9x squared. 1 squared is 1, and those are the outside. Inside, I'm going to multiply the 3x times the 1, and I'm done. The next one is going to be SOAP again. That's a sum of cubes. What I can really think of this as is x squared cubed. And that 8 is 2 cubed. Okay? So again, we're going to remember SOAP. Same sign. So this time it's a plus sign. Opposite, always positive. So the cube root of x to the 6th is x squared, and the cube root of 8 is 2. Square x squared and get x to the 4th. Square the 2 and get a 4. Multiply x squared times 2. And we're done. All right, and the next one, special formula. So this is a perfect square trinomial. You may or may not recognize it. This is that a plus b squared is going to be equal to a squared plus 2ab plus b squared. If you don't recognize it, it's fine. What multiplies to 9 and adds to 6? 3. 3 times 3. So you're going to get x plus 3 squared. And there's nothing wrong with doing that. And honestly, that's how I would do it. So what multiplies to 9? 3 times 3. We would have said x plus 3 times x plus 3, but really we should write that as x plus 3 squared. All right, this last one, it may be helpful if you can recognize this. This is a perfect square, so this would be 2x squared. Y is a perfect square, that'd be y squared. N minus 2 times 2x times y. It's nice if you can notice it, but again, you could use other methods to factor this. All right, so that means that the a term here is 2x. The y term here is, the b term here is y. And because of that minus sign, we're going to do subtraction. So that will be, 2x minus y squared. Grouping. Again, Algebra 1, when you have 4 terms, you can group the first 2 plus the last 2, x cubed plus x squared. And if you think you're done with factoring after this year, you were wrong. You will use it again in pre-calc. All right, take out the GCF of the first parenthesis. Take out the GCF again, and what you want are your parentheses to match. If they don't, you have a problem. So now we have a GCF of x plus 1 from the first term and the second term. And then we're left over with x squared plus 4. Same concept. So we have the first 2 plus the last 2, x cubed minus 2x squared. This is why I like to rewrite it, because of that negative there. All right, we'll take out an x squared. That gives us x minus 2. Here, I want to make sure I get x minus 2 as my answer, so I'm going to have to take out a negative 3 to make sure that they match. Here's my GCF again, so x minus 2, x squared minus 3. And I should always check if I could keep going. That x squared minus 3 may have been a perfect square or a difference of squares, but it's not. But if it is, I should keep going. All right, so in order to fact an expression